Hello everyone, I'm Clément Conand and I will introduce the work of the Digital Systems project of Capgemini Engineering. This presentation is about new environmental indicators for sustainable city of varying size scales with a focus on the use case of France. This study was conducted by Estelle Randria, Alexandre and myself and was funded by Altran part of Capgemini. I will start this presentation by the context and make the introduction of this study. This study has its roots on the bigger project about smart city. This project is based on three main thematics. The first one is the development of inclusive HMI to maximize digital inclusion. The second one is about the multimodal database and how to manage data from many different sources which are not related to each other. And finally, the use case of smart city is an application of the two other topics. This project have several objectives. We want to make data available for every people concerning their territory, to make those data understandable for as many users as possible, helping management of city governance in the big data era, find pertinent indicators to assess city advancement in ecological transition, and develop a web interface user-friendly to let all citizens access data and environmental score. And in our paper and in this presentation, we focus on the development of a new methodology to produce environment score. Now I will present a quick state of the art about the smart city before detailing the goals of our study. Existing studies are mainly focused on four topics: development of IoT sensors and deployment of many sensors to obtain new data, autonomous transportation and smart transportation like connected public transport or electric vehicles, the energy management and the reduction of smart light, for example, or the sustainability and ecology, with the question how to reduce pollution while creating an economic activity. Many indicators already exist, but they are difficult to understand for people who aren't working on the field. Data are difficult to find and often unavailable, which make it difficult to reproduce the methodology on a different use case. For example, indicators as a low level of education or no access to car are difficult to find. Existing data are located on different platforms for now, and in unrelated database make it difficult to use. Most of the methods are developed for big city and in different countries where there are lower constraints when it comes to privacy. In countries are applying more restrictive rules concerning privacy, applying some of the existing methods can be challenging. So we wanted to produce a new score meeting two main constraints. The first is only use open access and available data. This makes it easier to follow digital laws and to ensure that data are available. It is linked to our aim to make this methodology applicable for each French city, regardless of its size or localization. Then we tested our methodology on chosen cities of various sizes. And finally, we analyzed the obtained scores to see if statistical correlation can be made between our different scores. I will now introduce the methodology and the score calculation we developed. The indicators and the scores are based on data from 31 cities from Occitanie region in southwest France, with a very different size and focus on small cities mainly. We chose those cities on the base of available air pollution data to see the possible correlation with other topics. And we split the cities in 3 categories to study data, indicators, and scores. Cities 1 present less than 20,000 citizens. Cities 2 present between 20,000 and 100,000 citizens. And City 3 present more than 100,000 citizens. 3 steps are needed to obtain scores: gathering open data, producing indicators, and calculate scores. I will now detail those 3 steps. The first step was to find raw data and determine the topics. Here are all the data sources if you are interested in, and all the data used and the details of the methodology are present in the supplementary material of this publication. With those data, we produce key indicators for different topics. The topics chosen are poverty and unemployment score to compare with environmental scores, and the other scores are about water and air quality, energetical performance diagnostic for so EPD for the building isolation, electricity and gas consumption, and finally land use. With those indicators, we produced scores. That is the goal of this study. So all the scores present value between 0 and 100, where 0 is a bad score, like high pollution or high energy consumption, and 100 is a good score. Those scores are determined on different bases. Some are based on standards, limit concentration for air pollution, for example. Some are based on existing classification, like energetical performance diagnostic, and the other are based on statistical repartition, as the minimum and maximum poverty rates in France, for example. And I will now detail the score calculation for few of these scores. The water quality score is based on the comparison of concentration with French standard. So when the concentration reaches the limit of standards, the score is 0, and when there is no pollution, so 0 concentration, the score is 100. We can see here an example of a score for one city. The total water quality score is an average of all the subscores, and we added the number of measured indicators as a subscore to introduce the notion of available control data. In this example, the water quality is quite good, but the chlorine and pH could be improved. The air quality scores is based on the comparison with standards 2, the same as water quality. Subtopic represent different gases. Those gases are PM 2.5, O3, NO2, and SO2. They depend on 3 indicators. The first is the rate of data above the concentration limits. The second is the position of annual average compared to the concentration limits, and the third is the maximum concentration in the year compared to the concentration limit. The subscores for all gas are the average of those 3 indicators, and the total air quality score is the average of the subscores. In this example, 28% of the daily concentration are above the standards, which is quite huge. the average annual concentration reached 83% of the standard, and the maximum daily concentration is more than 3 times the limit. So that's why the score for this city and this gas is so low. The land use score is based on the rates of the different types and lands, and those data are available thanks to satellite image analysis. It is composed of the 2 detailed subtopics for artificial and natural lands, and natural lands score is obtained by adding forest, wetland, water surfaces, and natural lands. To conclude this part of on the scores calculation, the advantages of this method are that data are easy to find and available on government website. Indicators and scores are easy to calculate and detailed in the supplementary material of this publication. Scores of subtopic and topic can be used separately if people need just one part of the information. Scores are easy to understand. 0 is bad and 100 is good, no matter what the topic or the subtopic. And this methodology is easy to automate when we already automate the calculation and we are trying to automate data gathering. Now I will present the results and the discussion about the obtained scores and raw data. We split the data into 3 cities categories I told before, and the energy consumption is split in 3 components that are tertiary, industrial, and residential. Gas consumption showed 2 main patterns, one with industrial and tertiary components with an industrial major. The second is located between tertiary and residential component with a tertiary major, and in any case residential is the lower component. For the electrical consumption, the residential component is more important, but we observe that an important part of the cities present less than 35% of residential consumption. And in gas and electrical consumption, the patterns are not related to a specific city size. For the land use, we split data in 3 components that are artificial, natural, and agricultural. We can observe that a small city present less than 50% of artificial lands, and most of the medium and big city are mainly composed of artificial and agricultural lands. For most of those medium and big cities, natural lands present less than 20%. And we try to plot all the indicators to see if city size has an impact on the distribution of data. The second point is to have a clear trend on the raw data to validate the score calculation. Unemployment rates show that the bigger is the city and the higher is the unemployment. It is the same for annual NO2, max emission, and mean electrical consumption. The chlorine in drinkable water, a subscore, show that the big city have a lower concentration, and our hypothesis is that the big city have better water treatment plants, so they need less chlorine. Here are the final scores for the first part of the scores and subscores, and the other part is just after this one. So I'll start with the jobless and poverty scores that clearly show score decreasing when the size of the city increase. The trend is less clear for the water quality except for chlorine. The air pollution show very close scores for small and medium cities, but a lower score for big cities. And only NO2 show a clear decreasing of quality with the increasing of inhabitants, and it is logical because this gas mainly come from the combustion motors of cars. The other part of score are present here. For the energetical performance diagnostic score, the interpretation with the city size is quite difficult. For the electrical and land use, scores are decreasing when the city size increase. Finally, the gas consumption show lower scores for the small cities. And this could be because people in the small cities use more often the gas for heating their home. Then we decided to determine the Pearson correlation rate to see the connection that we can make between the different scores. In this correlation matrix, a value close to 1 determine strong correlation, when a value close to 0 determine a weak correlation. First, we looked at the energetic performance diagnostic. It has the higher correlation with unemployment poverty score, but the correlation is very low with the electricity consumption, so it could highlight that cities have that have good insulation, but high consumption. The PM 2.5 score, representing the concentration of nanoparticles, represent a good correlation with water quality and land use score. Chlorine in water present a good negative correlation with PM 2.5 score. This confirms what we saw before. Big cities have bad air quality but low concentration of chlorine in water. And finally, the population present negative correlation that are good for electricity consumption and land use, and a strong negative correlation with NO2 quality. To conclude this part about result and discussion, I would like to discuss the existing standard about air and water quality. So most of the air pollutant standard are not respect, and they have very high concentration. And the standard exists for SO2 and H2S, but very few stations are available to measure concentration. And for the water pollutant, there is no French standard for chlorine, and we need new study about the toxicity. So in conclusion, in the future work, I will finish with the summary and present the future works. We produce another environment score meeting two constraints. It only exploits open data access, and it is applicable to each French city, regardless to its size. This score can be easily used by city leaders to improve sustainability. It can be very useful for the small cities when they need to face the climatic and sustainable actual problematics. To complete this study, we are working on the user-friendly web application to present the scores. And we developed a method that we want easy to understand. So associated to this new methodology, we are developing an HMI to communicate those scores to all citizens and city leaders. Here are the table view of the interface with the name of the city, the indicators, the description of indicators, scores, and the status. And here is the map view, where we can select a city name, choose the indicators and the indicator score and status on the map. To continue this study, we would like to obtain a review of our indicators from municipalities, pursue the automation of score calculation, and add new topic leading to new scores, produce indicators for all the French cities, and provide cartography tools related to our indicators. I hope you enjoyed this presentation, and you can contact me on my email address and text to thank you for your attention.